Myrtle Beach was named the nation's second fastest growing metropolitan area. Usually just after Austin, Texas, Myrtle Beach makes the list for being a fast growing population. According to a 2010 census, Myrtle Beach population was at 218,000 people, and the population has been increasing at a rate of 5.7% per year. So we're given the initial amount, and instead of giving the growth factor, we're given the growth rate. So we're gonna have to change that to a factor. Because the first part says, write this as an exponential function, and this is gonna be the population since 2010. So the initial year is 2010. We want to figure out what the population is going to be each year after that. So we need to fill out our own y equals c times a to the x, and then we want to make sure we call it p of t and call it the appropriate name. So first of all, c is at 218,000 people that there were in 2010. And then the rate is 5.7%. So I'm going to use that growth rate to calculate the growth factor. So first of all, I want to get it out of being a percent. I'm going to divide by 100, which is going to give me 0.057. I don't want to take 218,000 and multiply it by just 0.057 because it's going to make it smaller, and the population is supposed to be growing. So to make sure it grows, we're going to add 1, which will take 100% of the population plus that 0.057 growth rate. So now we have our growth factor, and we're going to write this as P of t instead of a y equals, because that's what they tell us to write it as. It's going to be our initial amount of people, 218,000, times our growth factor is 1.05 to the t this time, not x. The next part says, according to the model P of t that we just found in part A, if the trend continues, what should the population of Myrtle Beach be this year? So this year, when I'm making this video, is 2022. So how many years has it been since 2010? You might already know. If not, you can subtract. It's been 12 years. So I want to plug in P of 12 and see how much this population has grown. It started out at 218,000 in 2010, but we know it's growing by a factor of 1.057, and we're going to raise it to 12 years and see just how much it's grown. We're going to round to the nearest whole number because we're talking about people. So I have 423,990, and then I need to look at my calculator and figure out how should we round this. It's going to be 991 people. And then this next part says, according to P of t, algebraically determine which year Myrtle Beach's population will reach 500,000. So when is P going to equal 500,000? We need to figure out what year that is. So we're going to find the t value that gives out 500,000 as the output. So I'm going to set this up as 500,000 equals 218,000 times 1.057 raised to the t. So this time I'm solving an exponential. I want to get that 1.057 to the t on one side by itself so that I can use my log to get rid of the exponential. So first of all, I need it on one side by itself. Right now it's multiplied by 218,000, so I need to divide both sides by 218,000. I'm going to do this in my graphing calculator. That way I can use math enter to reduce that fraction. So I'm going to do 500,000 divided by 218,000 and hit math enter, and that reduces to be 250 over 109 equals 1.057 raised to the t. Now we're trying to solve for t and it's stuck up in the exponent. So to bring it down, we're going to use logs. So we're going to use log base 1.057 of both sides 250 over 109 on that left side. And then on the right side, log of base 1.057 is going to get rid of that 1.057 base of the exponent. That way, we are just left with what is t. So t equals log base 1.057 of 250 over 109. So I can use a plus calculator. I'm going to use a TI-84 plus, which is going to be under the math menu. So I'm going to hit math and go all the way down to letter A, has log base as an option. And I can enter that and change the base of my logarithm to 1.057. Now this is only available on TI-84 plus and beyond. So check on your calculator, hit math, and scroll all the way down to log base so that you can switch out the base of the logarithm. And you're going to see that the t value is 14.97. And it says, but which year is this? So that's not our final answer. We need to add that to 2010. So our answer is going to be 2024. And we don't want to round up or anything. 14.97 just means towards the end of the year in 2024. It might take till December 2024 to get the population to be 500,000. The last piece is really just an opinion question. How accurate do you think this model is? And you can explain your reasons as to why you think this trend will continue or not. And you can argue either way. For me personally, I would say that we cannot continue to grow by 5.7% in the population. We're just going to run out of space. So they're building lots of houses, but at some point, there's just not going to be room for more houses. So I'm going to say this trend will likely not continue indefinitely. We're going to run out of space. Also, trends change, where maybe beach towns aren't it forever, and people want to move inland to the country and just have a farm or something like that. So you never know what the trend is going to be. I don't think it's going to grow by 5.7% indefinitely, but I think this model works for now. And you could argue the other way. Yes, I think it's going to continue. Myrtle Beach is amazing, and more people are going to keep coming and coming forever. There's going to be billions of people here in a century or something like that. Whatever you want to argue, it's an opinion piece, so there's no wrong answers for that.